Okay, so let's continue with where we had left, and then we'll come back to what happens to the poles when you include this CGD. So we were discussing this and I just left it as the Miller effect. Miller effect refers to the fact that when you have an impedance which connects input and output of an amplifier, then it appears like a very, very different impedance when looking in from the inside. Similarly, you can also look from the outside. We did not do that because that does not have much of direct use, but you can also look at what is Z out. Okay, so let me calculate Z in. Z out, you try and see what happens. So as we discussed yesterday, we are energizing with some V test, looking for some current I test, and we have this configuration. So how do you proceed here? So if I were to call this as say V1 and that node as say V2, right? Your V1 is nothing but V test. What is V2? Minus A times V test. So then I've already mentioned to you that no current enters the amplifier. So all the current has to move through this impedance Z. So what will that current be? Your I test would be V2 minus V1 by Z. Correct? Other way around, right? V1 minus V2 by Z. And if you put in the numbers, what will you get? This would be V test minus of minus, so plus A times V test Z, right? So your Z in will become Z divided by 1 plus A. Correct? So if your Z were actually 1 by j omega c, then Z in will be 1 j omega 1 plus A times c. So the conclusion is a capacitance between input and output appears as 1 plus A times C, looking from input. Okay. So this is a very important thing because you go back up here, right? You can associate you can explain, you get this expression for the pole, right? In the case of CGD equal to 0, you just GS by CGS. Now you are getting GS by CGS by GL CGD. So CGD connection is the capacitance that going from input to output, right? And gain is GM by GL. So you have to do this definition of this A is itself on the next slide. I have put this as minus, so just keep that in mind. Okay, so it should come as 1 plus GM by GL. However, because we have done a very approximate analysis, we are not getting that 1 plus. We are just getting the GM by GL. Okay. Now, what about A1? What about A2? Tell me, G by CGS? No. Okay, what is the expression for this when you don't have any CGD? We'll write that first. Your A2 becomes L by C dB. Correct? That's only to do with the output things. So one becomes, if I remember it, you get a CB plus C GD to 1 And what's next to it? G by GL into what? CD divided by CGS. Can all of you get this? No, this is correct. This is position, this is A2. The pole H is at minus A1 and minus A2. How did you get this? So we have an expert A1 and you said that A2 is basically the coefficient of this S squared term. So from, right, so just for people who catch that, this one A2 equal to quantity SGL divided by CGS into CG plus CDB. Okay, from that you should be able to work out A2 is. Okay, can you make some rough comments on the nature of A2? First, is it like larger, smaller? So what I want to do is to look at these two things. Okay, so also clarify that I yesterday just left a little awkward. Okay, so we need to know the relative magnitude of these various things. Okay, I goofed up yesterday in one of them. I'll correct that. But before that, okay, we already have discussed that CGS is greater than CGD and CD. Okay, and what does it mean? Much greater than means, right? So yeah, so this is basically what we are saying is this is roughly about 10 times either your CD or CD. Okay, and we had also talked about GL, but I will do that. For now, don't worry about. So GS and GL roughly assumed to be of the same order. Okay, don't worry too much about that. So and your GM by GL, right? This can be as high as 100, right? Because you are designing the amplifier, you want a high gain. So assume this is roughly 100. So this term will happen if you put GM by GL as 100 and CGD by CGH as 1 by 10, right? So I am saying this is roughly 100 and this term roughly 1 by 10. Why 1 by 10? Because CGS I am saying is 10 CGD, right? So this whole thing will come to a factor of 10. So what I am saying is all of this whole stuff, right? And denominator again, earlier you had just CDB, now it has become CDB plus C. Okay, so you have increased the denominator by say a factor of 2. If you assume that CGD is roughly approximately equal to CDB, you have increased the denominator by a factor of 2. You have increased the numerator by a factor of 8 or 11. So what you can comment is that the P2 is shifted right because of CD. Correct? And similarly, what about pole P1? Is this correct? So what I mean is that it's become more negative. Okay, so I should not write this. Instead of pole P2, let me just put this as the corner frequency due to P2, and I'll call this the corner frequency P1, right? Corner frequency due to P. What was I saying? So here, right, this omega 2 is the corner frequency due to P2. And what has happened to omega 2? You move omega 2 to the right. What about omega 1? You move to right or left? Think. what has happened omega 1? What happened? What is this expression, right? This is GS by CGS plus something. So where is it moved? To the left, right? So the corner frequency to P1 is shifted left. Which one? Yeah, that's why I this thing. I did a pole to. I think the corner frequency due to P1 and the corner frequency due to P2. That is omega 2 and omega 1. Okay, so this is a very important to keep in mind. And what is the other thing that say? We forgot to make some these are some statements on. These are statements on the poles. Can you tell me about the zero? When does a system demonstrate zeros? So the question I am asking, this is an important thing to keep in mind. Does demonstrate zeros? So just the thought experiment. Okay, say you have like you have say some cell phone tower, okay, is broadcasting, and places you have experienced, right, that you may have signal at one place, you may have signal 4 feet away, but the place where you are standing, only signal becomes 0. You have experienced this, right? So that is in some sense a zero or complete system. And why is that happening? Any ideas? Yes, some things cancel each other. And what are the many things that are cancelling? Yes, but to cancel you need more than one, right? If there's only one signal, you cancel it. To cancel something, you need something and copies of it. So where are the copies coming from? Exactly, right? So you can have this thing reflect from some building or something, right? Obstacle, and that is coming to one path. Similarly, you may have another obstacle and something like that, correct? So the sum of, say, if I call this as say y1 and this is y2, right? y1 of and this is y2 of t. If these phases are they happen to be equally matched, then you have a system where you can have a situation where at this particular point your y1 of t plus y2 of t is 0. Okay, happenstance. But what is the take home from this? You get zeros when? So the answer to this question, when do you get zeros? Can somebody revise what we just said? You get zero when you have multiple paths. Okay? Between again input and output. Now to your sit, and can you tell me where that multiple path is occurring? Just think. Where are the two paths? And in fact that allow to comment of the zero is even. Right? This was the circuit. What did we get as what is the expression for the zero? Where was your zero? Right? Your zero was at S equal to Gm by CGD was the zero. Okay. Now we have the mathematical expression for the zero, and I have told you that from your own intuition to understand that to have a zero you need multiple paths. Now I am asking you, look at this circuit and see if you can find out where the multiple paths is. should be very straightforward. If you look here, there are two terms, GM and D. It's a hint. Which is the path related to CGD? Right? So this is a path related to, that's one path. And the other path, right? Because you have called this VGS and you have said this is GMVGS. So that is one path by which your information is flowing. There is some VGS here, you will get GMVGS on the output, right? On the output port. So this is your path 1. And this is path 2. And depending on each of the paths is strong, you can have this particular 0 appearing either on the right or on the left in general, right? So there are two paths by which information is going from the left to the right. Correct? So now it becomes clear as to why you are obtaining the 0 in the system. If you did not have a CGD, you don't get a 0, right? Why? Because it becomes only a single path. Correct? So this physical intuition about you get zeros is very useful to keep in mind. Okay? Alright. So you have these two paths and that's what's responsible for your 0. Yes? Again, it's a very crude kind of thing, right? We are not talking very precisely. What I am saying here is basically that there is a VGS here. Then if you look at the output node V0, that there will be some contribution of V0 from the fact that you have a GM times VGS. So that is your path 1. You also have a contribution to this V0 from this coupling directly between input and output. That's your path 2. That's all. It's just one messy expression. We should understand whether that expression is reasonable or not. Correct? So by doing the analysis that we did, very crude analysis, we feel that it's a reasonable approximation. Correct? Okay. So what should we do to complete this whole story? And the reason I stopped here. You should take this and complete this diagram. I will do it only for the phase response. No, I will do magnitude response and I will ask you to do the phase response. The phase response is actually non-trivial. Okay. So what will happen now? What will happen to omega 2? So omega 1 first. It will move to the left. Everyone gets that? Why it moves to the left? Why is it moving to the left? Because of the Miller effect. Okay. That's the most essential take home of all what we have done. The fact that even if you have a small capacitor connecting input to output, the effect of that will be to kill your bandwidth. Right? Because of the fact that you will have so if I call this as omega 1 and I will do this as omega 1 with, I'll put a 0 there, that omega 2 with 0. That means you don't have any CGD. The other value of omega 1 will appear, say, over here. What omega 2? It will go to the right. Right? How much right? Depends. You don't know. But it will go to the right. So let's just assume that. Now this is your omega. And nothing else gotten. What is that? Is all that there exists? Or is there another frequency we should be worrying about? What is the transfer function completely? Right. We forgot. So far we already looked at the denominator. The numerator will give you a 0, right? So you have to worry about 0. And that 0 is here. So what value of your omega? Omega z is? What is omega z? So j omega z is Gm by CGD. Correct? And can you make a comment on what is omega z with respect to omega 1 and omega 2? In between, Gm is very, very large. Okay. So yeah, it's not very straightforward, but what was your expression for omega 1? Like this one, you should write this from just memory now. Okay, we have done it so times. So Gm divided by CGS plus GM by GL times CGD. Correct? Which one? No, the magnitude will be this only, right? Your omega 2 would be GL divided by something. Okay, so 1 plus something. So this was GD plus CD. Correct? I am not filling that up because I don't have space. So it is reasonable to expect that omega 1 is less than omega 2 less than omega. Right? What is the omega Z? Omega Z is GM by CGD. Yeah, the J is there. Everywhere there is a J. Everywhere there is a J. But you eat up the J. You want just the frequency. Okay. So how will this look? So I should have corner frequency there. Should have a frequency corresponding to this, and then should have say one more corresponding or omega Z. Okay, I am just putting it like. Can someone tell me quickly how it will look? This is omega. Okay, what should happen to until this point? Until omega 1, what again be? It will be the same, right? Nothing happens. So from here to here, the same. What happens after that? How much you roll off? Minus 20 dB per decade. And where will you roll off by with minus 20 until omega 2? So that will look, be careful when you draw this. It should be parallel to, yeah, it should be parallel to that previous. It should be parallel to that, right? And it should all the way until omega 2. Okay, fair up to there. This horizontal line has no meaning because it's on a log scale. It happens to be a horizontal line, so there is no meaning. Don't worry about what that value over here. Correct? What happens after omega 2? I must have minus 40 per decade, right? And I will have minus 40 where? Till omega Z, because omega is on the in the numerator, right? So it will compensate the minus 40 and make it again minus 20. So you should have minus 40 from here till there, and then again minus 20. So that minus 20 look, it should look back to that, something like that. Correct? So this will be minus 20. This will be minus 20. This would be, I am just writing minus 20. You know what that means, right? And that is minus 20. What happens to the phase? What happens to the phase? Think about this. Okay, I'm not going to do the phase. You think about it, discuss it. But I'll just leave you with one point which is important. If I just take only the numerator, okay, I take just this transfer function. Let me call sum of s, okay, as s times CGD. Sorry, what is the numerator what we were looking at? S CGD minus GM, whole thing divided by GL. Okay, so consider this. And what happens to your, that means what is your h of omega? It will be minus GM plus J omega CGD by GL. How will it look if you were to only draw the phase and this response for this? The Bode plot for this, how will it look? The 0. Oh, sorry, there's 1 0, correct. And the 0 will be at? The 0 will be a left half plane 0, right? It will be at the left, because this omega will be, so sorry, for zeros you have to work in the S plane. So it's a right half plane 0, sorry. S is equal to Gm by CGD is your right half plane 0. Correct? So, it's the same omega z. So, I will have some omega z over here. There will be some omega z. There will be some omega z. How will this thing look? Until omega z, what will it be? It will be flat. Again, I don't care what this horizontal black line, what's you. And after z, how will it look? It will go up. It has to go up when you take the magnitude, right? So it will go up at 20 dB per decade. What about this? Okay, what is the phase at, what's the phase at 0? What's the phase at 0? Quickly. The phase at 0 is pi, right? So this at 0 starts at pi and goes till pi by 2. Right? It starts at pi and goes to pi by 2. And at this corner frequency will be 3 pi by 4. Correct? So, something like that. So, this is your phase and that is the magnitude. So, point that you should keep in mind, think this, is that a right half plane 0, okay, induces phase what? Phase lead.